Let's talk a little bit about work, electrical power, mechanical power, and efficiency. This goes along with your winch activity. Basically, if you're doing notes, you're going to write down everything that's on here, follow along with me, and from here you should be able to complete your winch activity. So first we need to talk about work. Work is just force times distance. The unit is joules. And these little two, this doesn't mean Roman numeral 2, these two lines are supposed to be parallel. So it's a force that's parallel to a distance. Think of lifting a ball straight up. So the force is parallel to its distance. Something we need to know are units. Our units for force are newtons, and our unit for distance is meters. This is a little review on how to convert. Let me go through this real quick. Whenever I need to convert, I'll write my number that needs to be converted, and then I'll need to have some conversion.
Corbin Gurney, come to the office. Corbin, come to the office.
Sorry about that. And the students always ask, well, do I multiply or divide? You set the units to what you need to cancel. I need grams to cancel, so that tells me that I multiply these together, and then that's how I get 9.81 newtons. So that's just an example. We had 7,000 newtons over 24 meters, and we did 168,000 joules of work. So then we'll go into, we can do some mechanical power. Sometimes this is known as output power. And this is also in, not also, well, we're going to do another one that's in watts. Electrical power is in watts, and mechanical power is in watts as well. That's our unit. And it's our work that we just did over our time in seconds. So notice here's my 168,000 joules again, over 360 seconds. And that's 466.7 watts. To make that output happen, or to make that mechanical power work, I need some input power, and that's also known as electrical power. Also, the unit is watt. And I like to remember pigs in Venus, and this is written on your formula sheet as input power. Another reason I can remember electrical power is input power is my little saying that I just did, pigs in Venus. So notice that we have, in this example, I took a reading of 100 amps, and I took another reading of 12 volts, and I ended up with 12,000 watts. And then the last part is efficiency. This is measured in a percentage. Here's our symbol for efficiency. Don't forget that is the lowercase, let's see, oh, what is that one? Lowercase eta, or lowercase h. And here's our equation. Pout over pin times 100. Here's our 466 that we did earlier, right there. Here's our input power, 1200 watts that we did earlier. 0.389 times 100, we get 38.9%. Okay, that should make you armed and dangerous and ready to do your